Hello, welcome back to our series on Kubernetes for beginners. In our last video, we had discussed about YAML files and how they can be used to create Kubernetes resources. As we dive deeper into building Kubernetes concepts, especially around creating resources, it's important to revisit our main goal. With Kubernetes, our objective is to run our application inside containers, known as worker nodes. These worker nodes are within a cluster, but Kubernetes cannot place these containers or the images directly onto the worker nodes. Instead, it encapsulates each container into something called as a pod. Think of a pod as a box that holds one or more containers, which represents a single instance of our application. So, if you need multiple copies of your application running, you need to create multiple pods. So we can say that the pod is the smallest and most basic building block in Kubernetes, and it's the key unit that Kubernetes uses to manage and scale our applications. Each pod runs on a worker node, and Kubernetes takes care of where and how these pods are deployed, ensuring our application operates smoothly and efficiently. Now consider a simple setup where we have one node which contains a single pod, and this pods runs the single instance of a web application. However, consider a scenario where our number of users using our web application increases and we need to scale our application. This means we need to run multiple instances of our application. So, do we add multiple instances of our web application on the same pod? The answer is no. Adding another image to the same pod is not an option. Instead, we will add more pods on the same node. This is like adding more virtual machines or more servers, and hence creating multiple instances of our application. This way, each pod handles a portion of the load and help us to distribute the load effectively. What if we reach a point where adding more pods to the node is not possible? Then we can introduce additional nodes to the cluster. Each new node will host its own pods, allowing us to run more instances of our application. This process is known as load balancing, and we will explore how we can achieve it in our future videos. So does this mean that each pod need to have a one-to-one relationship with containers? Meaning each pod can only contain one container image? Not exactly. Pods can host multiple containers or multiple images, though they often serve different roles. For instance, you might have a web application container and a separate logging agent container within the same pod. The logging agent supports the main application by collecting and sending logs to a logging service. Running these containers together in a single pod ensures that the helper container follows the pod's lifecycle. That means when a pod containing web application is created, the helper container will also be created, and when the pod is deleted, the helper container will also get deleted. So what are the advantages of multi-container pods? Well, containers in the same pod can communicate via localhost and share resources like storage volumes and same network, which is ideal for tasks like logging or monitoring. Now let's have a look at the pod lifecycle. When a pod is first created, it enters the pending state. Once resources like network and storage are allocated, it moves to the running state. If it completes the task successfully, it transitions to the succeeded state. If it fails, it goes to the failed state. If the pod's status is unclear due to issues like node failure, it enters the unknown state. Okay, now in the last video, we had created a pod using a YAML file. Let's take a look at an example YAML definition for a Kubernetes pod. Just like any other Kubernetes resources file, our pod definition will include API version, kind, metadata, and spec. For our pod, the API version is v1 and the kind is pod. In the metadata, you will need to give your pod a name. This can be anything like nginx or any custom name, and you will also add labels here. Labels are where you can include custom information like environment is production or development and categories like front end or back end. Remember, the metadata section typically contains standard fields like name and labels, and any custom info should go into the labels. Moving on to the spec section, this is where you define the state of your pod. For example, you might specify a container with the name nginx and the image also set to the nginx. If you want to include multiple containers, you will add them here as well. Once you have set up your pod definition, save the file and apply it using kubectl apply -f mypod.yaml in your terminal. This command will create the pod based on your configuration. To check if pods are running, use the command kubectl get pods. If you need to delete a pod, just type kubectl delete pod and the pod name. For a faster and simpler way to create a pod, you can use the command kubectl run. For example, kubectl run nginx image and the image name. This will create a pod nginx and deploy the nginx image from the Docker Hub, which is a public repository for the Docker images. What if you want to change the name or rename the pod, or you want to edit any other field? You can use the command kubectl edit pod and the pod name. This to open the current pod configuration in your default text editor for in-place editing. Alternatively, you can edit the original YAML file, delete the existing pod, and apply the updated file. Keep in mind that direct editing of running pods isn't usually recommended in production due to potential disruptions or persistent issues. For a more controlled update process, consider using deployments, which we will cover in our upcoming video. That's it for this video. I hope you now have a solid understanding of pods and are ready to explore more Kubernetes resources. And if you enjoyed this video, make sure to like, share and subscribe. Thanks for watching and I'll see you in the next video.